Hi, good afternoon, and welcome back to Common Core Algebra II. Today's lesson is 10.8, Solving Fractional Equations. Now, this has to do with what we've been doing in the beginning part of Unit 10, and hopefully you'll know exactly what to do when you get to this point. So if you have a situation like A and B where we have just a proportion, it's very easy to solve these. I would just simply protect my binomials. All right, that's really important. And then simply cross multiply. So I don't know how you guys like to do it, but I guess some people like to do it like this. Some people like to circle them, whatever works for you. And it doesn't matter which side you're putting on which side. So I'll start with the 2 is equal to 5 times 4x plus 5. Okay, and then you're just going to solve this. And remember, we have an equal sign here, so this is solvable. So let's distribute. Make sure you're being very careful when you're distributing because I too make mistakes when I'm doing this. Now, because we do not have an x squared term in here, this is just going to be a linear function. So I like to usually keep my x's positive. So I'm going to bring my x to the right. So I get negative 2 is equal to 18x plus 25. And then minus 25 from both sides. And I'm going to get negative 27 is equal to 18x. Divide both sides by 18. And x is equal to negative 3 over 2. Easy enough, I hope. All right, so now taking a look at B, it's the same situation. And my first step is always to protect my binomials because sometimes it gets confusing when we cross multiply if you don't protect them. So here we're going to get 2 times 2 minus x is equal to x plus 1 times x minus 6. So here you can see on the right hand side we're going to end up with a quadratic. So here we're going to distribute 4 minus 2x is equal to, we're going to double distribute this, and you're going to get x squared minus 5x minus 6. Now, some people wonder why we can do that so quickly. Well, remember that this middle number right here is just the positive 1 minus 6, which is the negative 5. And this last number here is the positive 1 times negative 6, which is minus 6. So hopefully you're getting to the point where you can do that pretty quickly in your head. Now, we're also going to remember that when we solve a quadratic, we have to have this puppy equal to 0. So I'm going to take this minus 4 plus 2x. I'm going to line them up. So plus 2x and a minus 4. I line them up with my like terms. These cancel, and I get x squared minus 3x minus 10. And I'm going to put my equal 0 at the back because that's the way I like it. So now we have this quadratic. It's set equal to 0, and the next step will be to either factor if it is factorable, or if it's not, you use the quadratic formula. But this one does turn out to be factorable because I need two numbers that multiply to 10 and subtract to give me 3, and that's going to be 5 times 2, and I need the 5 to be negative, the 2 to be positive, so my answer turns out to be positive 5 and negative 2. Now, it's also very important to make sure that when you have a situation like this one, beware of your denominators. Because if you take a look here, you have a couple of denominators here where you're going to have some undefined values of x. So you have to be aware that your answers are not going to contradict that. So I know here that x cannot equal positive 2, and it cannot equal positive 6. Because those are the numbers that are going to make that those fractions undefined. So as you can see, your answers here being 5 and negative 2, it does not contradict what we have as undefined variables. Okay, so write down what you need to, and I will meet you at exercise 2. All right, so I say here, using the LCD, the least common denominator method, solve the equation. Because when you have an equation that involves fractions, the first thing you want to do is eliminate the fractions. Because even the oldest of adults, even the oldest of mathematicians, try to avoid fractions whenever possible. So again, we're going to look for the least common denominator. And again, I have 2, I have 4x, and I have 4x. So what's the largest number, I'm sorry, the smallest number that all three of those go into? And the answer is 4x, because we have 2 goes into 4, and 4, and then we have to worry about this x as well. So what we're going to do, as long as we multiply the entire equation through by the same value, it keeps it true. In other words, if I say x is equal to 2, and I multiply the whole thing through by 5, well, is 5x equal to 10? Of course, because if I divide by 5, I get x is equal to 2. All right, so just that's a little bit of a piece of information that you might need to know. So we're going to multiply this whole thing through by 4x. And when I do that, it means I'm multiplying the numerators, all of the numerators, by 4x. Now, some of you might be able to skip this step, but if it's easier for you to understand, just multiply it. You've got 4x times 1 over 2 minus, why don't we just be consistent, put the 4x first, minus 4x times 9 over 4x, which is equal to 4x times 3 over 4x. And then you can simplify from here. So this is going to simplify to 2, so I'm left with 2x. This is going to totally simplify here, so I'm going to get minus 9 is equal to, again, the 4x is going to simplify, and we're going to get 3. Now, another way that you could do it a little bit faster than that is just say, well, 2 goes in here to x. I'm left 2x times 1 is 2x. Here I have my 4x, and the 4's cancel here. The x's cancel here. I'm just left with the minus 9. And here the 4x's cancel, and I'm left with the 3. So that's kind of a little bit of a shortcut. But if you need to do that first step in blue, feel free to. So let me just take this away because I'm not doing anything with that. So this is a linear equation. And how do we solve linear equations? We have to isolate the variable. So we get the letters, the variables to the left side, we get the numbers to the right side. So 2x is equal to 12, divide both sides by 2, and x equals 6. And the next thing I always do is make sure that it's not contradicting, because if I look at all of my problems here, x cannot equal 0, because I have 4x in my denominator. So if x was 0, I would have 4 times 0 in the denominator, and we know that's not possible. Okay, so write down what you need to, and we'll move on. So in exercise 3, we're going to use the same technique that we just did. So we're going to take a look at our denominators, our 6, our 10, and our 15, and see what number is the smallest number all three of these go into evenly. Now, sometimes the easiest thing to do is start with 15, and you ask yourself, does 10 and 6 go into 15 evenly? And the answer is no. So let's think about the multiples of 15. How about times 2, which is 30? 30 works because 6 goes into 35 times and 10 goes into 33 times. So what that means is I'm going to take each one of these and I'm going to multiply them by 30. All right? Because we're looking for the values of x that solve this. So again, if we're going to write out that first step, which we don't necessarily need to, 30 times x minus 4 over 6 plus 30 times x minus 2 over 10 plus 30 times 31 over 15. Not plus, I'm sorry, equals. Oh, that was not supposed to happen. X minus 2 equals 30 times 31. Okay, so now the next step would be to do some simplifying. This is 5, so I get 5 times x minus 4 plus, this goes in 3 times x minus 2 equals, this was a 15, my apologies. This goes in twice, so this is equal to 62. 2 times 31. So I'm going to multiply it all out. So 5x, using our distributive property, minus 20 plus 3x minus 6 is equal to 62. Nice thing is here, we have a linear equation, which makes things a little bit easier. So let's combine some like terms. 8x minus 20 and minus 6 minus 26 is equal to 62. Add 26 to both sides using the additive inverse equals 88, and divide both sides by 8, and x is equal to 11. Oh, there's the answer. Multiple choice. Okay, so what I want you to do now in exercise 4, these equations can involve quadratic as well as root expressions. The key, though, remains the same. Multiple